the very first problem in these notes, which is called Integrating with Long Division and Completing the Square. It's a very lengthy title. We're going to be integrating with long division and completing the square. Very first problem, you've seen this exact same problem before. And in a previous video, I had worked through this problem with kind of a weird process with U substitution, and then I did it differently, which is the way I'm about to do it now. So you've seen this before. I'm going to go very quickly through this one because, well, you've seen it before. We're going to use synthetic division on this. I can use synthetic division when I am dividing by a linear term that has a leading coefficient of 1. Now I'm about to break my own rules in the next video or two, but for now, linear term with a leading coefficient of 1. So here goes. 4, 1, 2. Bring down the 1, 4 times 1 goes here, you get a 6. So if you're like, I've done this before, yeah, you have. Integral. Notice also that this is not a definite integral. So the directions on this would be like, just simplify. The answer won't be a number because we don't have a boundary here. We don't say, oh, we're finding the area from here to here. We're not finding the area from anywhere to anywhere. We're finding an antiderivative. So the derivative of our answer should give us this. All right, let's move on. I really had something that was to the first power. Now I have something to the 0 power. So 1 plus 6 over whatever we were dividing by in the first place, dx. Antiderivative of each term, antiderivative of 1 is x. Antiderivative of 6 over x minus 4. Okay, this entire denominator is collectively to the first power. If you are integrating something that has a denominator to the first power, then it's natural log, and you cannot take the log of a negative number unless you want to play with imaginary numbers, which is not this lesson. We do have a 6 in the front here, and we do have a c. And again, said this in a previous video, the other way we did it, we had x minus 4 here. We had x minus 4, I think, here. And that minus 4 would be absorbed into this c, because c is a constant. Okay? So we're going to move to the next problem, and it's going to look almost exactly like this one, only a little bit lengthier. And it looks like this. 6x squared 3x minus 23 over x plus 5. Okay, we can use synthetic division when we are dividing by a linear term, exponent is 1, degree is 1, when the leading coefficient is a 1, so let's use synthetic division. Let's put this one up and use this. -5, 6, 3, -23 in my head. Here's what just happened. We don't have any missing exponents as we count down. That's good to know. That'll come in handy later. 6, 3, -23. Bring down your 6, multiply, put it there, add, multiply, oh boy, 135. Put it there, add 112. Okay, I want to pause, make sure I'm right. Mental math is something that I should be much better at, but sometimes I struggle. I'm good. Okay. So what we're going to do is rewrite our integral with this. Okay, the original problem was a quadratic divided by linear. Therefore, the degree of this is going to be 1. So basically, we're reducing. It's like 2 minus 1 gives me, well, 6x to the 1. So 6x to the 1 minus 27 plus 112 over whatever I divided by in the first place, which was x plus 5. Divisor. Okay, we're ready to integrate now. Let's not ever confuse the simplification process with integration, because a lot of times people will be like, oh, well, I found my integral, and they won't put the integral symbol and the dx there, and like, we did it. No, we didn't. We divided. We haven't integrated. We haven't found the antiderivative. So let's do that. Antiderivative of 6x, we're going to go one term at a time. It's going to give me 3x squared. Antiderivative of -27 is going to give me -27x. And then, again, same idea. Let me write it a little more clearly this time. When you are integrating and you have a fraction, and it ends up looking, on a formula sheet, it looks like this. It looks like that right there. Okay, hope you can see it in that green. Is it showing up? I think so. All right. Notice this x is to the first power. If we undid some sort of undid the power rule on this, like the way we've been doing, then what I'd really have, let's ignore all that for a second, I would really have the integral of x to the -1 dx, and I'm tempted to just add 1 to my exponent. This is so wrong, don't write this. I'd add 1 to that exponent, and then I'd do old coefficient divided by new exponent, and what have you done? I'm not even going to put a plus c because the world just fell apart right there when I did that. So no, this is not going to work the traditional way. Just wanted to show you that. And because we have something to the first power in the denominator, the integral is natural log. Big long list of reasons why, but good rule to memorize. All this in the denominator is to the first power, and therefore we will use, well, a natural log. So 112 natural log of x plus 5, and then plus c. And there we go.